So in this video, I will be discussing what is mean time to failure, that is MTTF. So here MTTF, it is an estimate of the average or mean time until components first failure or disruption in the operation of the product, process, procedure or design occurs. So MTTF assumes that the product cannot resume any of its normal operation as it cannot be repaired. It is frequently used to describe the system or equipment reliability of use when estimated maintenance cost and its is significant even if there is no constant failure rate. So MTTF here, it is mathematically expressed as sigma is equal to T of I by N of I to 1. So here if you use that expression, apply integration considering the functionality with respect to time. So that ft is equal to df of t by dt, that is equal to minus of dr of t by dt. So like this you can take the MTTF function in terms of reliability. So if integrate further with respect to 0 to alpha with the negative term, integrating with respect to t with respect to time, so you are going to get the MTTF expression in terms of reliability, Laplace transform in terms of RT. So with respect to MTTF, there are different models like time dependent hazard model, where particular expressions are there to evaluate. Constant hazardous model, where it is reliability expression has been derived. Linear hazardous model, where you are going to have a different expression to make the measurement. Non-linear hazardous model, gamma model, stress dependent hazard model, Markov model. So system reliability models are expressed in series or parallel connection, where it will be having a number of components which will be connected in series or parallel. So you'll be able to evaluate the performance of the system or subsystem by connecting different elements in the series or parallel connection. So here you can see if there are n number of components at the entry, there will be 1 and 2 until n where it will be output. So here probability of that component in the working time in the series system, whatever all on good condition it is considered, based on that you will be able to express the reliability of the system. So if the connection is in parallel, the parallel system where components are connected in parallel and the system does not fail, even one component is in good working condition, the system only fails only when all the components are failed. So here you can see all the components are added, so the probability of the system with respect to time it is considered. So what all the components are working, that it is carried out in the series connection, and combining all the components which are working, you'll be able to consider it as a function and find out with respect to the expression. So failure rate also with expression you'll be able to calculate. So reliability of the system in the parallel connection you will be able to calculate. So several examples related to reliability of the system in place in series and parallel component also I'll be able to do. You'll be able to calculate MTTF and MTBF by using the different expressions. So the system reliability, whether it is in series or in parallel connection, you'll be able to calculate with the required expression very easily.